So for our project, we wanted to work on something that would have a real long impact. So we chose texting and driving. It's an issue that's really not that known right now. Well, it's known, but like people don't really think it's an issue, and that's part of the problem. So currently, every year, 1.6 million vehicle accidents involve cell phones, which is roughly a quarter of all vehicle accidents in the United States. And texting while driving causes 11 teenage deaths a day. So within this RCOS meeting, someone in the U.S. will have died from texting and driving, which is ridiculous. This amounts to about 3,000 deaths a year, and it's currently the leading cause of teenage deaths in America. So this is definitely a huge problem, and the problem is that most people don't think it's a problem. So 77% of young adults think they can text and drive, and ultimately, it's our goal to bring awareness to the dangers of texting and driving. So the problem with people not thinking it's a problem is that even if you make it a law, most people are going to follow it because they have their own beliefs. So what we want to do is we want to be able to hard code in a way to prevent or even warn people about the dangers of texting and driving into smartphones. So the way we're going to do this is by having the smartphone detect speeds that the person is traveling at. So when the person reaches a certain speed, then we know that the person is driving. So then we can send a message or prevent them from texting. So our options are, first of all, the GPS. However, the GPS uses a lot of power, so it's not very feasible because we want this application to be able to run in the background at all times. The accelerometer uses 16 times less current requirements, so that's what we're looking at right now. So in theory, is it best one?
So we're trying to use like the accelerometer to determine velocity at which a device is moving at.
Can you guys see that? I don't really know.
Yeah, you can see.
Okay, so the accelerometer measures, acceleration at different axes. So obviously, we know from calculus that if we take the integral of acceleration, we get velocity, and if we want to take the integral of that again, we get distance. So this is the, the theory behind it. And if we take a look at, we're going to do a live demo right now. Yes, this is with my smartphone right now. Okay. So I'm just going to show you real quick the first app that I made, and it's right now it's just taking accelerometer values from the iPhone, so you can see it updates extremely quickly. This is at the fastest speed, which is at 1 millisecond. So at the top you can see the triaxial accelerometer values. And
if you can run faster, move it faster, that's the acceleration increase.
Yes. That's the accelerometer. All right. So obviously the number values don't really mean much for us right now. So I decided it was worth it to make a graphical interface. So, all right, the surface isn't that flat, but let's see if this works. Okay. So right now this is the accelerometer graph on my phone right now. So. All right, I apologize, the axes are a little off, but the top two are the X and Y axes, and they're zeroed right now. The Z coordinate axis is the up and down right now, so obviously we have gravity, so Z is at 1 right now because I'm using 1 as the units as the g-force, so 1 would be like acceleration of gravity. So obviously, as you can see, it's actually pretty accurate. So
Seems like it's lagging.
Is it lagging?
Yeah.
Alright, so if I change the orientation of the phone, you can see the gravity is changing. Yeah, that's not good. Alright, so you can see that it's fairly accurate if I move it around. Alright, there we go. Alright, so now I'm going to try to use the formula and plug it right in and see what happens. So now we're trying in a second. Alright, so right now we're looking at velocity. So this is taking the first integral of speed, and you can see immediately the z-axis goes down. This is because of gravity, and the other axes shoot up in random directions. Now this is the core problem with taking the integral of real life values, because any noise or error that you get will get compounded significantly when you take the integral of it. This is as opposed to maybe taking the derivative. And if you take the derivative of something, any bias, it's immediately cancels out because it only factors in the change. So what we can do is, first of all, to get rid of the gravity issue, we have a feature that's called gyroscope that we can use. Now it shows up. Sorry,
Display's
yeah,
lagging right
it's
now.
lagging. I'll give you a second. Okay, so, all right, here we go. So this is the gyroscope, and what this does is it measures rotational acceleration within the yaw pitch and that kind of thing. It's still lagging. All right, so as you can see, it's also extremely accurate. Okay. All right, I'm really sorry. I don't know why this is lagging so much. All right, so yeah, so basically this measures how much the foam rotates, and if we measure the amount of foam that the foam rotates, then we can figure out which the orientation of the foam towards gravity. And because we can keep it as a unit vector, and that I kept gravity as a unit of 1, then we can just subtract it directly from the acceleration values that we get. So I'm going to try to do that, and also for the simplicity of time, I'm going to put all the features that I implemented so far, which includes, I guess, a high-pass frequency, high-pass filter, and I think it's dampening system as well. So we're going to try that out first, and see how that works out. So this is speed again, but with the additional gyroscope speed. So, all right, so it seems pretty smooth right now. We can just move it to the side. Okay. Oh, I'm sorry, just the wrong one. Let's try that again. So I'm going to move to the side and the back. And show up.
Yeah, it's there.
I want to show you the curve now. All right, so then I just moved to the side and back, and you can see values are staying relatively centered. I'm going to move it up and down, and you can see that it's measuring speed quite nicely. So this is with some more work. This is definitely useful in our presentation, in our application actually. So also what we wanted to look at is we came upon distance. So alright, so back to the slide. Alright, so when the error compounds as we integrate more. So oh yeah, so it's called sensor fusion when you use multiple different sensor sensors to obtain information that you normally can't reach with only a single sensor. So let's take a look at distance. Distance is a lot harder because they're integrated twice, and I don't think anyone's been able to make a very accurate distance measurement yet with accelerometer yet, so don't expect too much out of this, but let's take a look.
The distance measuring thing was tried before for blind people navigating inside a building, which floor they are in to calculate that.
Yeah, so there's definitely a lot of applications where this could go to, but the problem is it's not extremely accurate for now. And that's one of the big issues right now with smartphones. And so, yeah, we're looking to possibly improve that in the future. And also, I think my partner Sammy's working on a keyboard.
So I've been working with Android development, and I've been focusing on the keyboard side of things, so trying to develop hard-coded keyboard and then implement this software that Tom was working on, but translate it to Java and Android stuff. So my goal is to make a keyboard that basically disables itself after if a certain velocity is detected. So essentially, you won't be able to type while driving. And I've been working on that.
So that's our.
Yeah, that has to be there even for iPhone, right? So once you find the accelerator, you have to disable that.
The problem is iPhone doesn't let you do that right now because it's a lot, closed. But yeah, maybe in the future we'll see.
I should. Yeah.
Sorry.
What you're doing is known as inertial navigation.
Yeah.
You should. Have you looked it up before?
Yeah, I have, and I think Google did a presentation about this a couple years ago, and they basically said it's not very possible unless you want to get very in-depth with the math or getting better stuff.
You just need better sensors.
Yeah, that's also an issue.
That was essentially what I was going to say, but there's actually a chip that's already spent the last 3 years developing to build that. That's a smaller than penny. So that, I think, just recently went into manufacturing. So you might see that in the future.
What if I'm the passenger in the car?
I'm sorry?
What if I'm the passenger?
All right, so we discussed this issue, and we decided that we could also, at the very least, like make a pop-up warning, like, kind of like how
Waze.
I guess how tobacco products have those certain general warnings. Like a long time ago, people used to think that smoking was good, but then now everyone knows that it's not. And that has to do with the advertisement they put on the labels.
Most phones have GPS when I use that.
Oh, I think that's battery consumption.
Yeah, it doesn't move much. I don't know. Like I know on mine, my GPS is always on. And I get
I think it uses.
I want to use like Google Maps. I
No.
don't see the transfer once a day.
No, when you
compare to the radio, the GPS is not. It's a couple of
compare to the accelerator.
Yeah.
Or if you look at, this is what I pulled from the Apple iPhone 4S spreadsheet, and it uses 16 times more.
Right. It's still not very much. Considering the capacity of something like that. I think that's the fact that compared to like the cell radio, we're transferring data from someone else's
Right, but we want this to be able to run like in the background at all times. So I don't know. From my experience, the GPS runs out. But yeah, it's obviously
Yeah, so the solution with what's on a cell phone is that it's an IMU, which is an inertial measurement unit, so that internally it can detect rotation very well and to some degree velocity and position. But what you need is an external sensor that is accurate but not necessarily precise. Interview, reset it, and you can remove all the drift. So the solution would be to every once in a while try to use GPS, which won't use too much more battery,
Right.
but we'll be able to reset the system as we keep going.
And also, there's like the magnometer we have looked at, which you know, it looks at the waves of the, you know, or I guess, and then you can reset the position from that because the gyroscope also drifts after a while.
Have you considered using the GPS to just check if you're on the road rather than, so it doesn't like pop up if you're like running around?
Yeah, that's definitely an option. Yeah, that's definitely a good option.
With turning the GPS on and off, though, it actually consumes way more power trying to find its mission direction. So the turning on will use 15 or 20 times as much power. If you're going to be turning on and off, say your interval is like 1 hour usage.
In the back.
Yeah, you have to come forward, so it's okay, NPC, it's okay, you can shout.
Okay, sorry. First off, make sure you definitely address the passenger issues. That's going to make it a non-starter. If 3 of the 4 people in the average car get warnings on their phone saying you can't text if you're driving, 3 of the 4 people in the car aren't driving. Second off, you have to look into if iOS 8 greatly expands the keyboard API, like massively. You can actually do things with it that you couldn't before, as far as replacing the keyboard even. So blocking out the keyboard would be actually doable with that change without a doubt. It'd be a lot easier to get access to that. I'm definitely looking for those APIs if you can do that.
Yeah, I think we heard something about that, so yeah, we'll definitely look into that.
Oh yeah, is your code on GitHub by any chance?
Oh, it's not.
Okay.
Yeah, sorry.
If you know, if you get the chance, be awesome.
All right, yeah.
We have to.
Is the amount of power required for doing all of the calculations, is that guaranteed to be less than the difference between the amount of GPS consumes and the amount of the accelerometer consumes?
I'm not sure right now, but it's not very difficult to, you know, it's just some math, you know, algorithms. I assume sensors use a lot more battery.
They're also very variable.
Okay, thank you.
Next, we have the plan of study.